components done. So the program we want to look at writing is one that's called write a program that prompts the user for a radius and then prints the area and circumference of a circle. So we want to think about how we might go about doing this. You'll notice that I already have a framework here for my program. I've got the name of the class, I've got my main method set up, so we really want to talk about how we're going to go about getting some code written that goes in the middle of that method. A couple things I want to point out about algorithm design. Algorithm design is really the core of being a programmer. And really the goal here is to get us engaged in what I'll call computational thinking. In other words, we want to start thinking about how to solve problems in the context of computer science. And so it can be a little difficult because, this is new and we're trying to look at different ways to think, and we're still trying to learn all of these new things that allow us to think in these new ways. So let's start off with a definition of an algorithm. And an algorithm is a step-by-step solution to a problem. And so a step-by-step solution to a problem, everybody's familiar with this process. So a good example would be a recipe. If you have ever cooked anything, a recipe is a great example of a process that you have followed to get some delicious food. If you have ever given anybody directions, you've designed algorithms. In other words, you have put together a series of instructions that would help somebody get from point A to point B. So I think what's really important to remember is that you've designed algorithms before. It's just that you haven't necessarily defined those algorithms in the context of computer science. So what we want to try to do here is we want to try to identify a process for solving the problems, and we're really going to look at how to tackle tightly scoped programming assignments because that's going to be the most useful to you right now. One of the things I want to mention is that working with algorithm design is a lifelong process. I mean, programmers are never done finding good solutions to problems or refining their step-by-step solutions to the problems. And one of the terms I like to give students early on in their programming career is this term called refactoring. And what refactoring means is basically go back and knowing what you now know, knowing what you have learned, fix old code. So let's say, for example, we're writing a program and we give it our best solution, and 6 months goes by and we've been writing code for 6 months and we're getting better at it and we're learning. If you were to go back and look at that code that you wrote 6 months ago, you'd be like, oh, why did we do it like this? What's the problem? So the idea of refactoring is always going back to code you've written previously, and if you have the time and resources, fixing it. Obviously, that capability is an ideal situation. Not every company wants to take the time to go back and make working code better. But I think everybody's had this experience where you'll write a paper as a freshman in college, and then maybe like a junior or senior, you'll go back and look at that paper or look at something you've written in high school and be like, oh, I can't believe I wrote that. So refactoring is just kind of go back, knowing what you've learned, and fix or redesign old code. So anyway, we want to come up with a process. And I'm going to start with a couple of things that are really important here. I think we're going to look at what we know. So we always want to define that and what our inputs are and what our outputs are. So this process is probably very similar to one that you've used in math to solve word problems, but it's not going to be, it'll be a little bit modified for what we're going to do. So I'm going to look at this program and I'm going to look at what are the things that I need to do. Well, right now I need to prompt the user for a radius. So I'm going to write these inline. So one of my outputs is going to be like ask user enter radius, right? I'm going to write this just kind of quick and easy. One of my inputs is going to be to read the radius from the user. Where did I get this from? Well, if I read this first sentence up on line 1, it's telling me, okay, prompt the user is an output because I need to have the computer give an instruction to the human on the other end of the keyboard. And then what I need to do is have the human enter a radius, and a radius is a single value. And what you'll notice is that is my only input, okay? Because you'll notice that the program will then print the area. The radius is my only input. Because then you'll notice the other output in the program, it'll print the area and circumference of a circular. These are going to be calculated. So what we can do is we can say here, like, well, I need to print the area and circumference of a circle. Okay, so output area of a circle And then finally I need to output circumference of a circle. Hopefully I get the calculations in the right order. And what do I need to do in the middle? Well, I've identified my inputs and my outputs, right? What I need to print, what I need to read in. And a couple of things I may need also to identify what I know or what I might need to know. So let's clarify that, what we know and what we need to know. So in this case, you might need to know the formula for calculating the area and circumference of a circle. And I know off the top of my head they might be backwards, but there's 2 times pi times the radius, I think that's the area, and then pi times r to the second power. I forget which one. 2 pi r. Actually, this is the circumference, and 2 pi pi r squared is going to be the area. So we need to get these mathematical equations together. So it's important that, if you don't know the equations for answering the given programming problem, you've got to go find them. Sometimes you may need to go find more information about a process. It might not even be a refined mathematical idea. So it might be something like upload a photo to Instagram. So the things that you know and things you don't know. Well, you probably know that somebody needs an Instagram account, but you'll be like, well, what don't I know? You'll be like, I don't know. How do I log into Instagram for somebody? And how do I take data and from a camera on a smartphone and upload it in Instagram? And so there might be a lot of things you don't know. It's this process of identifying what you do and don't know and need to achieve in a program. And that's kind of what this whole course is about. So don't feel frustrated when you get to this part, right? Our goal with this lecture is to kind of identify get the easy things out of the way. So we've got our circumference and we've got our area calculations figured out. So what we need to actually do then is go about and calculate area and circumference. And I guess I should have probably put that here. And notice how I'm using comments to kind of lay out my program before I ever write it. So my comments are providing kind of guidance in terms of pseudocode that I can utilize to write this program. So from there we can just start to write program, and I'll put enter the radius, and down here I'm going to need to read a value in. So sometimes what you're going to notice too is that there's a couple of things that I left out. So I said that I needed to know the value of how to calculate the area and circumference of a circle, but one of the other things that I left out is that I need to read a value in. So I need to use a scanner object. So sometimes this other idea is that, what we know, what we need to know, these tend to fall into 2 categories, right? And so what we want to identify maybe under those 2 categories is we want to make sure that these are logic and programming related. In other words, I need to have the logic of or the capability to do the math to calculate the problems or to calculate the solutions that I want. And then I also need to have information about those programming structures that I need to get my problem done. So in this case, I realized, oh yeah, right, I need to import the scanner class because I need to read some data in from the user. So I'm going to make a scanner. And I'll try to keep talking while I type. So now I know I've got my output, enter the radius. I like to make mine look a little cleaner, so I'll put a little colon and a space in there. Then I'm going to read the value in from the scanner. And then what I can do is I need to read this into a variable called radius. And we'll make it a float or make it a double. Double radius equals s dot next double. We'll read that in from the command line. And you're saying, well, how do I know that I need to read this into a variable called radius? Well, I know that my one identified input is read the radius from the user. Whenever I read a value from the user, I want to store it into a variable. Okay, why is my variable a double? Well, the radius could have it's a real number, so it could have a fractional component. And so we want to make sure that we can store that. So in this case, this sets me up. I need the scanner object to help me get information from the keyboard. Then I need this method to help me read data into this specific variable. And from there, I can go ahead and I can do my calculations. I can either do the calculations as I output them, well, yeah, let's do it like that. So how do I want to do this? 2 approaches. I can either calculate and store, or calculate and print. And so let's do calculate and print first. So let's do system.println. Area is colon space. And then what I'll do is right here inside of this set of parentheses, I can go ahead and I know that my I also know that math has a pi constant in it, so I'm going to use math.pi. I could also use 3.14159 something and put radius in there. And then what I'm going to do is cheat and copy this because that'll save me some typing. And circumference. Oh, you know what? Did I get those backwards? Area is pi r squared, I think. If I'm wrong, just yell at me. So pi times radius squared. And I know I'm going to use math.radius to the second power. And this process of typing these things out, I can put some extra spaces in here to help me read this. But what you'll notice is that I've got a specific set of calculations happening right inside of the print statement. So I decided to calculate and print because the only time I ever need these values are right at the moment I print them out. I could have chosen to store them into variables. So let's go ahead and run this. I think I'm going to need to save it. There we go. Oh, awesome. And I got an error. And actually, this is a really great error to have because it shows you that everybody makes errors when they write code. So what's nice is I got this weird error. I wasn't real sure what it was. If I go here and I look, you'll notice that the error that I've made is that I put radius period 2 when I meant to put radius comma 2. You spend as much time fixing bugs in code as you do writing code and doing any other. I'd say you probably spend half your time writing the code and half your time fixing bugs in it. It's just what programming is, so don't feel bad. Everybody makes mistakes. Somebody made a great comment to me one time. They said, I used to think I was bad at programming till I realized everybody's bad at programming. And I like that comment because it's true. We're all learning. We all make mistakes. It's, you know, if programming was easy or if machines could write code, we wouldn't have jobs. So anyway, let's run this and see what outputs we get. Compile it just to make sure it's compiled. Run it. This time I will enter the radius. And make this area a little bigger so we can see the answer. So we get some big numbers. Let's run it again. And everything seems to be running fine. Hopefully this helps a little bit in identifying a process. Again, for these simple little programs, I'll also give you one other extra bonus tip. When given programs, use the new skills